So in this example, we continue on the back of the result from the previous, the earlier part of this same question. So we know that if dp dt equal to kp, then this implies that p is equal to p naught, the initial population, times e to the kt. And this is a popular result that if we memorize it, it should be useful. So here they're also telling us that given that k is equal to 2.5, find the time that to the nearest minute for the population to reach twice its original size. So for part B, we have p 2p naught. So p is now 2p naught is equal to p naught e to the 2.5t. So we want to find the time that it takes for the population to double its size. So that means that 2 divided by p naught, 2 is equal to e to the 2.5t. Taking the natural log of both sides, ln2 is equal to ln e to the 2.5t. So we're here now going to be using the rules that if you have ln a to the x, this is the same as x ln a. So we're going to use that rule, and then we're going to use the second rule that ln e is equal to 1. So we have ln2 is equal to 2.5t, ln e, which means that ln2 is equal to 2.5t, since ln e is the same as 1. If we continue to solve for t, t is going to be equal to 1 over 2.5 ln2. So we type this into the calculator, and then we will get the final answer. So we have 1 over 2.5 times ln2. We're going to get this to be equal to 0.277 hours. So t is initially being measured in hours. So ideally, we want to be able to, t is initially being measured in days. So rather than hours, it should be days. So now we want to convert this into, so we want to convert this. If we go back here, we want to give time to the nearest minute. So here, we know that there are 24 hours in one day, and then in minutes, that would be times by 60. So 0.277, we convert that to hours, and then we convert that to minutes. So if we multiply the calculated answer by 24, and then again by 60, we're going to get t to be equal to 399 minutes. So to the nearest minute, it would be 399 minutes. If we convert that to hours and minutes, we're going to get, it's going to be equal to 6 hours and 39 minutes. Okay, so that represents the approach for part B. So in part C now, we're told that we have an improved model. And the improved model now is that dp dt is lambda p cos lambda t. And we're of course, p naught is the initial population, etc. So we're going to now solve for the, we're now going to solve the differential equation for the improved model. So let's have a look at how we would go about doing that. All right, so here, let's set up ourselves. All right. right, so with this model, again, we're going to separate and integrate. We're going to move the P's with the DP's and the T's with the DT's. So we're going to have the following. So for part C, we're now going to say 1 over P. So 1 over P DP is equal to lambda cos lambda T dt. And then we integrate as per usual. So we're going to have ln P is going to be equal to, when you integrate conjugate sign, and you're going to divide by the derivative of the argument. So that will end up with lambda over lambda sine lambda T plus C. So ln P is equal to sine lambda T plus C. We're going to E both sides in order to get rid of the natural log. All right, so we're going to have P is equal to E to the C times E to the sine lambda T. So we're now going to rewrite this as P is equal to A and E to the sine T, sine lambda T. So we're going to solve for A using the fact that the initial population is P naught when T is equal to 0. So when T equals 0, P is equal to P naught. So we substitute that into the equation that we have. So P naught is equal to A E to the 0, which is equal to A. So that therefore means that our final equation will be P is equal to P naught E to the sine lambda T. Okay, so we can let's have a look at what we have so far. All right, so that gives us a full picture of what we have so far. Now in this one, in part D, we are told that lambda is equal to 2.5. I want to find the time to the nearest minute for the population to reach double its size as before. All right, so for part D, 0. So we're going to have 2P naught is equal to P naught E to the sine 2.5T. And whenever we are solving these type of equations, we know that they were in radians. So if we rearrange, so we're going to have 2 is equal to E to the sine 2.5T. We're going to take the natural log of both sides. So ln of course will cancel out here. So this will be sine 2.5T. So T, so if we do sine inverse, so 2.5T is equal to sine inverse of ln2, and then T is equal to 1 over 2.5 sine inverse of ln2. All right, so we can solve for that. So 1 over 2.5 times sine inverse of ln2. So when we type that into the calculator, we're going to get T is equal to 0.306 days. We times that by 20, we times that by 24, so 0.306. Multiply by 24, multiply by 60, gives us the answer in minutes. So times 24 times 60. So we get T to be equal to 441 minutes to the nearest minute. All right, and we can leave the final answer in that form.